In yesterday's lesson, I know in my class in particular, we had some questions about inverse operations. Now remember, inverse operations means the opposite of. So to look at a really basic example, 3 plus 2 equals 5. The inverse operation of that is where we take the answer and subtract one of our options from the beginning. So 5 take away 3 equals 2. And 5 take away 2 equals 3. This way we know our answer was right, because when we do the inverse operation, it matches. So how do we apply that to the more complicated work we were doing yesterday in division? Well, if you take something like 33 divided by 3 equals 10. If I want to check that, I will then take the answer. 10 times 3 equals 30. Oh, wait a minute. It doesn't match up. I've made a mistake somewhere. So by using the inverse operation, you can see if you've made a mistake or not. So now you can go back and go, oh, 10 doesn't seem right. Oh, it's 11. So let's check that now. 11 times 3 equals 33. Oh, that does match. Now, by doing this, you're able to check your own work, and that's the benefit of that, okay? In today's problem, well, actually, let's take a step back to nuts about number. I saw in Ruby, Miss Kearns had posted about remainders. So if we take a question like this, 337, and I'll write it how it is on the slides. Remember that slash, it's actually a fraction, is our division. So 337 divided by 5, I would rewrite it like this myself, like that. And we ask ourselves, how many times does 5 fit into 3? Well, 0 times. So we have to carry over that 100 to the tens as well. So now that becomes 33. How many times does 5 go into 33? Well, this is where our multiplication comes into play. 5, 10, 15, 20, 25, 30. So the answer is 6. But 5 times 6 is only 30, and we have 33. So we have to carry over the little 3 there, and that becomes 37. So we ask ourselves, how many times does 5 go into 37? Well, the answer is 7. So I just did it for 30, so 35 is one more. But 35 to 37, there's 2 left over. So our remainder is 2, but we don't do R2 anymore. That's more of our infants maths. No, we turn that into a fraction, okay, 2 over 5, like that. I see a lot of people doing the decimal for their answer. I'm not quite sure we're being as truthful as possible. We might be using a calculator for that one, because to work that out, it's quite tricky, and I'm not quite sure many of us are able to do that. If I was to say to you, what's the decimal of 2 over 5, it might be hard for some of you to figure that out, to convert that. So always do it like this, and that's our remainder there. So the comment was that the math is incorrect. Well, that doesn't make any sense. It's just the fact that we need to have a remainder here like that. So that's just the nuts about number. In today's lesson, you're presented with a problem that looks like this. Something, something, 0 divided by 6 equals something, okay? So it might be 110 divided by 6. It might be 250 divided by 6, but you have to input the numbers, okay? This relates back to factors. Let's do a different example. I'll just hide that for a second. What if it was something, something, 0 divided by 7? Okay, I would start doing the factors of 7. Well, 7, 14, well, I might just start by doing my times tables. 28, 35, 42. Oh, hang on a minute. If I can get to 42, so 6 times 7 is 42. If I throw in the 4, 2 like that, do you think that might work? Well, let's see. Let's do the strategy we have been practicing. 7 into 420. 7 goes into 4 0 times, and that becomes 42. 7 into 42 goes 6 times. 7 into 0 goes 0 times. So the answer is 60. So there you have it. So 420 divided by 7 equals 60. And I got to that answer by just running out my times tables. You might find out, well, hang on a minute. 140 divided by 7 also might find us an answer. If I do the same working out, how many times does 7 go into 1? 0. How many times is 7 going to 14? 2. How many times is 7 going to 0? 0, 20. Oh. So 140 divided by 7 equals 20. Okay, so the key to working out our problem for today is by writing out your 6 times tables. Okay, by doing that, you're able to find some answers that you can slot in here because our 1's place value holder is a 0. Okay, so that's a good way to go about today's problem. It does ask you to check using the inverse operation. So if I was to check this one here to do the inverse operation, I would then go, okay, well, 20 times 7, what does that equal? 7 times 0 is 0, 7 times 2 is 14. Does that match here? Oh, yes, it does. So I am correct. And that's how we use the inverse operation. It also gets you to find a couple of different solutions. What's the highest possible solution and the lowest possible solution? So that's how you're going to be able to complete your work today. If you have any questions, have them ready for the Zoom. Otherwise, post them in the Google Classroom.